In this session, we are going to discuss about data types and operators. We have primitive data types and non-primitive data types in Java. So primitive data types are predefined data types that is coming up with the language itself. So we have integer, float, boolean, character, long as primitive data types. So they are kind of a fundamental types, which is offered by the language. And then non-primitive data types are something which is not defined by the programming language, and it has to be defined. It is defined by the user. Um, for an example, if I wanted to plot a point in a graph, I would like to have the x-axis and y-axis value. Let's assume they are integers. They are basically numbers. So I will say like 3 comma 2. So here 3 is a primitive data type, which is an integer, and 2 is a primitive data type, that is again an integer. So I need two integers coming up together forming a user defined data type, which is point. So this type of user defined data types are non-primitive data types we can form using structures like class, arrays, etc. So we are going to learn about the structures, how to create this non-primitive data types with the help of primitive data types in the subsequent sessions. So Java offers the following primitive data types. We have byte, short, int, long. These are integer representations. And if you want to go with floating point numbers, we have float and double. We also have boolean to represent true or false value, and then we have character to represent the characters. You would be knowing, like, we always talk about 8-bit, 64-bit memory, 32-bit. We also talk about like 16-bit systems. 16 bits are kind of old, but nowadays we are using 64-bit memory locations. So what do you mean by 64-bit is, one memory location, can store 64 bits of data. So when I say 64-bit, a bit of data means you can store 0 or 1 in that actually. Finally, in memory, you only store zeros and ones, as I said before. So you cannot store characters there, you cannot store images there. Finally, everything is going to be converted or represented as binaries, which is zeros and ones. So if I wanted to represent a integer number, like say if I want to store a number like 125, I need to represent that in binary. So what I will first do is I will convert that number into binary, and I will be placing them in the memory locations. So in order to represent a number like 125, I would need 8 bits. We'll see how 125 number to store it in memory, why it needs 8 bits. We will see that in a while actually. But if you understand, like if I want to store a number like 125, I need 8 bits of memory locations to hold it. If I wanted to go beyond 127 or minus 128, I would like to go for a other data type like short. So suppose if I want to represent 200, I cannot do it with the byte, because byte range is supporting only minus 128 to plus 127. So I have to go with a bigger data type, which is short, which is going to offer me 16 bits of memory location. If I want to go beyond that, like 32767, then I have to use integer data type, which is int, and that is going to give me 32 bits of memory location. And you would see the range, a very big range that you can represent with by using integer. If you want to go beyond this integer range, you can always use long actually, which is going to be a very big range of numbers you can represent using long, because it is 64 bits. The counterpart of integer is float, which is 32 bits to represent decimal point numbers, and the counterpart of long is going to be double, which is going to be representing 64 bits. Coming to character, if I want to store a character, like say if I want to store the character A, uh, I have to basically store it as a binary, because always we have to convert it into zeros and ones and store it in the memory. So each character in any language will have some will be assigned one number. Let's say capital A is assigned as 65. 65 is the number representation of capital A, and I'll be storing 65 in binary format in memory. So when I access that 65 as character, I'll be getting it as A. Similarly, each character will be having some ASCII code, or we call it as a number, and we we store the binary form of that into the memory. So character needs 16 bits of memory location basically. So we'll come to understand how this range is formed. We said like byte, you know, with the help of byte data type, I can store only numbers between 128 to 127. So how do we decide that? For that, we need to understand what is binary and what is decimal. So here, if I have say 0 in binary is 0 in decimal, 1 in binary is 1 in decimal, 2 in, if there is no number called 2 in binary because it is a base 2 system. So you have 0, you have 1, and you have to form a number only with 0 and 1. Actually, you cannot form 2 or 3 in binary. So the next number after 1 is going to be 1 0, which can be formed with zeros and ones. So it's nothing but 10. And after that, it is going to be 11. That is the fourth number you can form. Um, After 11, there is no numbers that you can form with just zeros and ones. You can form, the next number will be only 100 actually after 11. So it is going to be 100. If you observe the pattern, you see that the last digit is getting 0 1 0 1 0 1 like that. The second last digit is getting 0 0 and then 1 1. If you see uh, the whole thing, the pattern is getting repeated 0 0 0 1 1 0 1 1. Again, it will be repeated for the third digit as 1 here. So if you understand this, 0 represents decimal 0, 1 represents decimal 1, 1 0 represents decimal 2, 1 1 represents decimal 3. Similarly, if you go beyond, if you go like this, you will get 7 ones in the range which it represents 127 in decimal. So how do we, if I give a number, how do you convert that? For, let's say I'm giving 000011. What is the decimal value of it? Okay, you can go through like this and find it out, but there is an easier way to do that. Let's see how we can convert a binary into a decimal. So this is how you convert binary into decimal. Take the number and multiply with the 2 power its position. The first one is going to be 0th position, 1th position, 2th position, like that actually. So multiply the 1 with 2 power 0, the second one with 2 power 1, third is 0 0 into 2 power 2, 0 into 2 power 3, which is going to give us all 0. So as you see in the spread in the slide, you just calculate these values and then try to add them together to get the decimal number. So this is the way to convert a binary to decimal. So if I put 7 ones, how to convert into decimal is just doing the same calculation again and adding up all of them together to get the decimal number that corresponds to 7 ones in binary. So we reserve the last digit as a sign bit actually, which is going to represent 0. 0 means it is a positive number. If it is 1, the next 7 digits is representing a negative number. That's how we find it out for a that's how we represent as whether the number is a positive or a negative number. So the reverse calculation is, like say if I want to understand, hey, I want to store a number 127, how many bits I would need actually. So for that you need to know, you have to convert that decimal number into binary so that you know how many bits are needed to do that actually. So how do you convert a decimal into binary? Is just divide by 2 continuously. So and take the reminders. So here you are dividing 127 by 2, you are getting 63. Divide by 2 again, you get 1 as a reminder. Divide 63 by 2, you get 31 and 1 as a reminder. Like that, if you do till it gets 0, you get 7 ones. If you go from bottom to up, you get 7 ones here. So 7 ones means you need 7 bits basically to represent 127. But the 127 is a positive number. You need the 8th bit to be a sign bit, which will be 0 which says that the 127 is a positive number. 7 bits for storing the number, 1 bit for a sign bit. So you need 8 bits minimum to represent 127. That is nothing but a byte. If you go beyond 127, then you need to go for the short data type, because byte can hold only 127 because it can have only 8 bits of data. Okay, coming to the operators, Java supports all these operators. So we are not going to look at all these operators now. Basically, to classify, Java supports arithmetic operators, Boolean operators, and then relational operators. So arithmetic operators, as you know, it is plus, minus, star, slash, and then modulus operator. We also support like a plus plus operator, which is going to add by 1 by default. And if you can also use plus plus 2, means it is going to add the current number to 2. So we have we call that as increment and decrement operators. So and you also see something called precedence. So which means that the plus plus operator has more precedence than the plus operator. Plus plus minus and star slash, these operators has more precedence than the less than, greater than, which is the relational operators. So we will be doing a lot of programs, and then we'll be learning these operators while we do the programs instead of learning from this chart actually. um, that's it for this session. We'll catch up with the next session. Thank you.